So we have H0, which is P is 0.07, 7%. We think the proportion has decreased, so H1 is P is less than 0.07. Whenever you find a critical region, you look for something that's below the significance level. So for y equals 0 to lie in the critical region, the probability that y equals 0 should be below 5%. To find the probability of y equals 0, we can use the formula. So NC0, P, which is 0.07 to the power of 0, then 1 minus P to the power of n minus 0. These are both 1. So this becomes 0.93 to the power of n is less than 0.05. You could use trial and error, or you can use logs. So if you log both sides, log 0.93 to the n is less than log 0.05. Bring the n in front, n log 0.93 is less than log 0.05. To get n on its own, divide by log 3. But if you check what log 0.93 is on your calculator, you'll see that it's negative. So when you divide by log of 0.93, it will flip the sign to a greater than. Type that into your calculator, you get n is greater than 41.2 something. So therefore the smallest value of n that's greater than 41.2 is 42. In part B, this time 8% of the pairs weigh more than 180 grams. The farmer believes that the proportion has changed, so it's a two-tailed test. H1 will be P is not equal to 0.08 with an n value of 75, halving the significance level, which is 2.5%. It says using a suitable approximation, so you have to use an approximation. The only type of approximation we use in FS1 is a Poisson approximation. And we can see the n value is large and the p value is small, so it makes sense to use a Poisson approximation. So the binomial with an n value of 75 and a p value of 0.08 turns into a Poisson. We find the average lambda value for Poisson by timesing n and p. We get 6. So there are two methods that you can use. You can either use the critical region method or the p-value method. So the critical region method you can use your calculator or the tables. So we're using lambda of 6. Find something that is below 0.025. That will be x equals 1. So probability x is less than or equal to 1 is 0.0173. So your first critical region is x is less than or equal to 1. Next, you find something that's above 0.975. So you do 1 take away this number, 0.975. So find something above 0.975 in the tables on your calculator. So that would be 11, and x is 11. So probability x is less than or equal to 11 is 0.9799. We want the inequality sign to be a greater than or equal to. So do 1 minus. That flips it to x is greater than or equal to 12. 1 minus gives you 0.0201. So the second critical region is x is greater than or equal to 12. So your critical regions are x is less than or equal to 1 or x greater than or equal to 12. Now we found that there were 11 of them weighing more than 180 grams, so we need to see if 11 lies in our critical region. 11 is not less than or equal to 1. It's also not greater than or equal to 12. So 11 is not in the critical region. So do not reject H0. Or you can say accept H0. So we're accepting that H0 is true. Now the farmer believed that the proportion has changed, so we can say that the farmer is wrong. So we can conclude that there's not enough evidence to support the farmer's belief. Or you can say not enough evidence to suggest that there's been a change in the proportion of pairs weighing more than 180 grams. A quick way is using the p-value method. So we found that there were 11 weighing more than 180 grams, so we use this value of 11. Now the tricky bit is to figure out, do I use a less than or equal to or a greater than or equal to sign here? Well, we can think about what makes more sense. So we were expecting, using our Poisson value of 6, we were expecting 6 of them to weigh more than 180 grams. We actually found that there were 11 of them weighing more than 180 grams. So you have to ask yourself, does it make sense to test that the proportion has increased or the proportion has decreased? Well, 11 is more than 6, so it makes sense to test that the proportion has gone up. So we use a greater than or equal to sign. So we work out that probability. So it's sort of like we're treating it like a one-tail test. So work out the probability that x is greater than or equal to 11 by doing 1 minus less than or equal to 10. Gives us 0.0426. So this is known as the p-value. If the p-value is less than the significance level, then you reject H0. Remember, this is actually a two-tailed test, so we need to compare it to 0.025. It's actually more than 0.025. So we only reject if the p-value is less than the significance level. This time it's more than, so we do not reject H0 or accept H0. And then we can write down the same conclusion.